Have you ever wondered how database can manage so much amount of data? How they are so consistent? When you create an application or run a query on that, how they are able to run very fast? This is due to normalization. It's a method through which we can manage our database in such a way that there is no redundancy. Let's understand what is normalization first. Normalization is a method through which we try to make our database consistent. We try to remove redundancies like duplicate data, null values, so on and so forth. So in this topic, we are going to understand how normalization helps us to reduce or improve our database quality. When we talk about normalization, there are majorly three forms of normalization. These forms help us to reduce the redundancy within our databases. First normal form, second normal form, and the third normal form. There are few more normal forms which we will talk at the end. So let's start with an example where I have an existing table which is storing some information. We'll implement these normalization forms through which we can improve the database quality. Let's start with understanding the first normal form. In this normal form, we have to make sure our tables satisfy two primary conditions. The first condition is all the attributes should be atomic. What do you mean by atomic? Atomic means in an attribute there shouldn't be multiple values. Let's say if there are multiple values, we need to remove those. And the second condition is each element should be unique. Based on this, I have a table over here which is unnormalized. Let's have a look into that. So herein we have a unnormalized table which is storing order ID, customer name, items, and then order date. So this is basically a table which is storing order information. Now if you can see, the items column is storing multiple values like TV and laptop, headphone, mouse, keyboard, so on and so forth. So this is not normalized. If I have to normalize this, after applying the first normal form, I am going to remove that duplicate values or repeated values, I would say. After adding the atomic values, now items will store TV, laptop, phone, headphone, mouse, keyboard individually. So I'm going to repeat my attribute list, but herein I'll have different values. So instead of storing in one single section, I'm going to store in multiple format. That's how I'm going to apply my first normal form. And the second criteria was to not have duplicate values. So when we say duplicate values, we mean no duplicate rows. Definitely over here, order ID is getting repeated, but if you can see, all the rows are unique. So hence we have applied the first normal form. Herein my data doesn't consist any duplicate rows and all the values are atomic. Now let's just try to understand the second normal form. For second normal form, the table should be applied with the first normal form, and the second criteria is there shouldn't be any partial dependency, which means that if there is any non-attribute key, it should completely depend on the primary key. Now what do you mean by primary key? Primary key is the identifier of the table. If you have any table, it should have a constraint through which I'll be able to identify my table. And if there is any other attribute, then it should totally dependent on that primary key. Let's have a look in our table. So herein we did implement our first normal form, and due to which we were able to remove all the values. So herein I do have TV and laptop and then headphones and mouse divided. But here you can see the customer name is still getting repeated whenever we place an order, and that's a redundancy. How do we remove that? So if I have to implement second normal form, what I can do, I can divide my tables into multiple parts, wherein I can define a primary key based on which I can mention the attribute. So here I have a table where if I implement the normalization, you can see I have divided my tables into multiple parts. So firstly, I have created an order table which defines what order I am creating. Based on every order, I am going to generate order ID and then order date. Hence, my identifier is totally dependent on my non-identifier. Similarly, I have created a customer table wherein customer is identified by customer ID, that is the primary key for that table, and then customer name. So if multiple orders are being placed, I'll be able to get one single value only. Similarly, it goes for order items as well. So if there are items, I can define with each of them having those individual values. This makes much more easier for me to segregate and manage my database. Now if I have to do any queries, we can create these relations based on which I'll be able to manage and fetch my data. And for that, we have joins. We can discuss joins in further videos. Now let's just talk about the last and major normal form is third normal form. Herein, again, it should be optimized with the second normal form. And the next criteria is there shouldn't be any transitive dependencies. Let's try to understand with an example. So let's see that in our example. In our table, let's say we try to add a field wherein we also add customer's address. Now, if that field gets added, there is a possibility it adds a transitive dependency. So for that, we bifurcate our table into much more detail and then create another table as customer address wherein we are eliminating that transitive dependency as well. So herein I will store customer ID, customer name, and for customer address, based on this primary key, that is customer ID, I'm going to store that address, reducing that transitive dependency and making my database much more optimized. So these are major three normal forms. There are few more called as BCNF, 4th NF, 5th NF and 6th NF, which will optimize your database much more. But if you implement these major three optimizations or normal forms, your database will be at the max. There won't be need of any other type of normalizations. If you want, I can definitely cover those topics as well. But these are the fundamentals when it comes to normalization. Implement these type of normalizations, you will be able to query much more faster, improve your database quality, and you will be able to access your database in much more faster way. That's it for this video. Happy learning!